let's have a look up. So, no prizes for guessing what the next rule would be about. So the first rule was about multiplying, then the next rule will be about dividing. Just before I do that, a little trick. Some of the questions you might notice would have a square in it. Something like this. And in fact, when you think about it, that's really the same thing as sine x multiplied by sine x. So me just putting the square in was just as a little trick, okay? Squaring, you can use the product rule, because square means multiply by itself. So for the questions with a square, just do that. Then use the product rule. So for example here, it would be cos x sine x plus sine x cos x. So that's sine x cos x plus sine x cos x. So actually it will be 2 sine x cos x. Okay, let's have a look at the next lesson then. So again, if you think the derivative of f over g is f derivative over g derivative, well then you'll be wrong. Not as simple as that again. So let's have a look at what the formula is. So this lesson is called the Quotient Rule. You can see it at the top there. So we have yx equals fx over gx. So yx plus h minus yx all over h. That's fx plus h over gx plus h minus fx over gx all over h. Okay, so just write that bit down. Yes, it's not in the exam, but I still want you to write it down to improve your mind. That's right. Some people might say I'm crazy. I don't think so. I think it's good for you. Okay, so again, there's a bit of a trick here for this one. This h is a little bit annoying there, so what I'm just going to do is I'm just going to write it like this, just so I don't have to keep writing a big fraction. Now we can put these two together. I'll use the cross here, multiply the bottom and then these two minus these two. Add the fractions together. There's always one person that says, here. So just to prevent that, what I'm doing is multiply the bottoms and then you cross AD plus BC, okay? That's all I'm doing here. So I add the two together and I'll get fx plus h gx minus fx gx plus h. And this is divided by h over 1. This is like a h over 1. The reason I did that is to remind you of elementary school. When you divide by h over 1, it's the same as multiplying by 1 over h. Yes? So this is actually multiplied by 1 over h if you want. And here you have gx plus h. And here you have gx. And here you have fx plus h, gx, and here you have gx plus h, fx with a minus. And again, we add something in the middle to help us simplify. So what I add here is minus fx gx plus fx gx. So what's in common to the first two that I can take out? What's in common here and here? Gx. Correct. So I have fx plus h minus fx times gx. And here, what's in common with these two? Fx, yeah. Minus fx gx plus h minus gx. All over h gx plus h gx. Now you can, if you want, you can forget about those g's just for a moment and just focus on this part. So what happens here when the h goes to 0? What does this piece become? Derivative of f. And what will this piece become? G. And in red here, what will this piece become? G squared, very good. So you're left with f derivative x gx minus fx g derivative x all over gx squared. This is the quotient rule. Or to write it a little bit shorter, if you have y equals f over g, the derivative is the bottom squared, the bottom times the derivative of the top minus the top times derivative of the bottom. This is the quotient rule. So I usually say this in words rather than remembering it. It's the bottom squared, the bottom times the derivative of the top minus the top times derivative of the bottom. After 100 of them, you won't need to think anymore. Okay, can we have a look at an example? Yeah. So I want to do an example where we know the answer already. If I said y equals sine x over cos x, that's the same as tan x. What's the derivative of tan x? 1 over cos squared x, isn't it? So let's see if we do get 1 over cos squared x. So I'm going to do this directly by words. The bottom squared. So far that looks good. The bottom times the derivative of the top minus the top times derivative of the bottom. Now if you don't like that, no problem. Just write the formula out. Bottom squared, bottom times derivative of the top minus top times derivative of the bottom. Yeah, so what we have here is cos squared x plus sine squared x, which is indeed 1. So you're left with 1 over cos squared x, which is exactly what we thought it should be. So it works. Let me give you one to try. Got that? Yep. Okay, try this one for me. Not as difficult. Let's say, I don't know, sine x over x. That's a good one. Alright. Derivative, please. Okay, got an answer here? Yeah? So, the answer is the bottom squared, the bottom times derivative of the top minus the top times derivative of the bottom, which is just 1, so that's the answer. That's it? Yeah? Can I give you another one? Try this one. That's right. You're going to need the product rule and the quotient rule. Which rule do you use first? Product or quotient? As is the way, nobody agrees for this. So half of you think product and half of you think quotient. Who feels like they definitely know the answer? No? Which product or quotient? You see, but you don't look like you definitely know the answer. Yeah, that's more confident, yeah. So you're saying product, and you would be wrong. The answer is quotient. So actually the quotient rule comes first and then the product rule. Because the product is part of the fraction. It's the top part of the fraction. We think of this as a fraction first, then the product comes.
You can use only product for. You can use only product for. Like minus.
Technically, yes, you could do this by only using the product rule, but that's not what I want. I want the quotient rule as well. But you're right, there is a way to do this by only using the product rule. That is true. Malik, if I put the sine x down the bottom, then you couldn't, yes. Maybe next time I'll do that. Yes? Yeah. Let's have a look at it. So, first we need the quotient rule, which is the bottom squared. And then it's the bottom times the derivative of the top. But the top is a product, so we need the product rule. So that would be EX sine X plus EX cos X. So we continue with the quotient rule. The bottom squared, the bottom times derivative of the top minus the top times derivative of the bottom. And that's the answer. It's difficult because there's a couple of things going on at the same time. We'll do another example like this. Try this one for me, let me see. X EX over sine X. There you go. Try this one. We'll do it again. Something similar. That was the first example there. Oh, sorry, the board. Let's see if we put it there. Yeah. Let's have a look at this one. So please watch carefully for this one. So the quotient rule, the bottom squared, the bottom times derivative of the top, which is now a product rule. Derivative of the top is a product. So that would be 1 EX plus X EX. Now we return back to the quotient rule. So if you recall, it was bottom squared, bottom times derivative of the top. Next, what's next? Minus the top times derivative of the bottom, which is cos X. So this is the derivative here. There's layers. And this is what they like in the exam. They like giving you questions that require the product and the quotient rule.
Why we don't use the product rule in the X multiplied by EX?
Here's the product rule here. So what are you asking me?
The other one.
Oh, here? Here?
Yeah.
Well, the rule is, if I write in words, it's the bottom squared, the bottom times derivative of the top minus the top times derivative of the bottom. So the top is the product. So we only need the product rule for this part because this is where I ask for the derivative of the top. Whereas when I see the top again, I just want the top by itself, no derivative. For this part, the derivative is on the bottom. Yeah. Let me think. Another one maybe, or let you try something tricky.
No.
Nah, trickier. Okay, can I scroll down? I want you to find a maximum. Let me see. Oh, come on. Off the phone. I'm trying to think of something really juicy. Okay, feel like there'll be an EX in it. Think. Maybe. Okay, maybe I won't make it too difficult. I'll put an EX over an X, I think. Yes, it's not as bad as it looks. I tried to make it more difficult, trust me. Try this. Find the maximum. And X is any real number except, of course, 0. Sometimes they ask you to show that it doesn't have a maximum. So if there's no answer here, it means it has no maximum. So I think there is a maximum, but if there's not, no problem. Tell me why there's not then. Got an answer? Okay, let's have a look. So the derivative here, actually, you know what, I said maximum, but I don't care if it's a maximum or a minimum, so I'll just change to find the turning point. Okay, so the derivative is the bottom squared, the bottom times derivative of the top minus the top times derivative of the bottom. We want this to equal 0. Right, so does anybody have any ideas on how to solve this?
Do we use formula?
Nope. Yeah, multiply by x squared. If this is equal to 0, it can only be because the top is equal to 0. This can never make it equal to 0, and this is never equal to 0. It can only be 0 if the top of the fraction is 0. So if I have a fraction a over b equals 0, it's only because the top is 0. The bottom, I don't care about it. It's the top that makes it 0. So I need to solve this, which means I need to solve this. I don't care about the EX because that can't be 0. Only the x minus 1 could be 0, which means x could be 1, which means y equals E. Yeah? So the answer is 1E. Yeah? Yes?
Do you have
Continue?
to find the maximum?
No. Okay. I don't think there's any other weird types. No. Listen. So just please note for the exam, they like to mix these questions with at least two rules. So the example I did, like here, that's okay because you have two things. You have turning point and quotient rule. Here you have product rule and quotient rule. My point is, in the exam, they like to put at least two types of problems together for this. So it could be a product and a quotient, a product and a maximum, a quotient and a maximum. Do you get what I'm saying? They never keep it as simple as what's the derivative, use the product rule. It's a little too simple. You know, if I gave you an exam question like y equals x sine x, what's the derivative? That's too simple for the exam because you can write the answer down directly in one step. They never do this in the exam, okay? It's at least two parts to the question. You understand what I'm saying? Yeah? Okay, so can you try these quotient rules for a few minutes then?